Welcome to Total Network Operations, the project with a podcast dedicated to all the hardworking network operators like you who deliver, secure, manage, analyze, and replay all the packets. We talk about great ideas in NetOps so you can make informed decisions and to spur constructive dialogue between vendors, NetOps teams, and across the entire NetOps community. I'm your friendly neighborhood podcast host, Scott Robon. Well, part of what we do on Total Network Operations is to proactively look at new tools and tech that are useful in taking a holistic view of NetOps and your whole tech stack and how it should support key business and mission goals. One of the evolving technologies we need to address is the digital twin. It's not a brand new concept, and many of us have a vague idea of a digital twin is and what it does. But we're here today to wipe out that imprecision and our lack of certainty around digital twins. To help us accomplish this today, we have Darren Fulwell, the field CTO of IP Fabric, who's come from 10base2 and Novell NetWare to what can be done through digital twins, how they're connected to AI for ops, and beyond. We're going to get into some details and definitions of digital twin, automation and autonomy, the power of abstraction layers, and what you need to take from this for your career and the future of networks you'll work on. So Darren, welcome to the podcast. Please tell us about yourself, what led you to your roles in tech and networking, and how you got into NetOps.
Well, thanks for inviting me, Scott. It's always good to talk to you. So good to finally do it on a recording. So it's good to be here. Yeah, I'm Darren Fulwell. I've been in networking for an awful long time, or it feels like an awful long time. I was that 1980s micro kid.
Sure.
Grew up with the home computers, with the basic programming, with the assembly language, with the tinkering with electronics to build speech synthesizers, all of those kinds of things.
That was you. That was you.
That was me. Come on, it was so many of us, but I was just steeped in that. I was never ever going to do anything but be in this incredible IT space. But networking came to me a little later, but not that much later. I was, as you've rightly pointed out, 10base2, crawling around under desks, cabling together PCs in order to get them to be able to share file server, disk space, and that kind of thing. That was very much where networking started for me. We didn't have networked applications. We didn't have, all of those things. We barely had email at that stage. We were
right
in the corporate environments. It was all about what resources can we share in order to just make computers able to work together in some shape or form. Obviously, lived through the whole World Wide Web explosion, and as a result, well, here we are today, having completely changed everything, including that network becoming the absolute foundation of everything digital. And I think that, for me, has been an absolute joy of a ride, really, because I've come from tinkering with bits of cable to planning, designing, architecting massive scale enterprise networks, and really coming to understand how foundationally our businesses are built on so much of this IT, which in turn depends on the availability of the very thing that we put together for it. So yeah, love it.
So that ramp up to where you are today, let's do a little preview of what IP Fabric does,
Sure.
who you are, and we'll kind of preview the digital twin concept. We'll get into it more as we go, but tell us a little bit up front so we know what we're referring to. So our thoughts have mental furniture to sit in as we go, so to speak.
No, it's a good one, and because IP Fabric comes very much from that same network engineering background. Our co-founders were network consultants, right, working for some of the biggest consultants in Europe, dealing with some of the biggest networks, and they'd often walk into a new customer, sit down with the documentation they were presented with, and literally say, "What the heck is this?" It's the challenges. Everyone listening to this will know the challenges of being able to lay out an understanding of their own network in a form that they can come back to time after time and make sure that people understand what's going on. It's just so difficult to do and maintain. As consultants, Pavel and Roman and the other guys would come in and say, this makes no sense. They'd have to start again from scratch, effectively mapping that network out for themselves. So it's as simple, the foundation of the company is as simple as, how can we do this better? What can we do to do that? And so ultimately they came up with a means of automatically discovering customer networks, to mapping out the dependencies through those, so that they were able to provide their consultancy services. That's
Sure.
where it comes from.
And was that a pivot from very consulting focused initially to turning into a product company? Because that's the sense I get for you guys today.
Absolutely. So it was very much a question of, once they realized and appreciated the advantage that brought to them as consultants, they could see, actually, this is something that would be incredibly useful for all of the people who are our customers now. And so there's that realization that actually manual documentation, manual processes to maintain all of this, manual processes to pass on understanding of the network from one person to another, is not big, not clever, and subject to all kinds of problems with consistency and with accuracy and with timeliness, because of course you're relying on these things being kept up to date whenever there's change. And if you and I know one thing, it's that the change is inevitable, both planned and unplanned. It just happens, and so you can't keep up with it.
For sure. Well, let's touch on, okay, we know each other through our network automation circles. I think we met early on when the first AutoCon event was being planned in 2023. And we're seeing increasing maturity, customers moving forward in their network automation activities. But you and I have had some interesting conversation about automation versus autonomy. Tell me what you're thinking on that front. And what's the big picture? How does automation support autonomy and the other things that we need to wrap around it?
Yeah, I think, and it was one of the early discussions in AutoCon 0, I think, where we started talking, going back, almost looking back at what it would take to be to create self-driving networks. I know it's an old concept that keeps coming back around, but it's this idea of, if customers our users don't want to have to know about all the mechanics of how networks work. So how can we build networks that are consumable to them, that change and adjust with their needs, but that don't cause us problems when we're trying to try and maintain them and so on. So it's all about the self-driving element. Find the things that are wrong, react to the things that are wrong, and fix them automatically in some shape or form. But you've got to have that sort of closed loop approach. Now, we talk a lot about closed loop automation, but it's very limited in its scope more often than not, because it's all about saying, right, well, this thing's wrong. I know how to fix that thing. Go fix that thing. Test that thing is now fixed, and go again, and essentially working that through. But and automation is the enabler for that. I think this is one thing that having listened to how things have changed with AutoCon and where we started from, and where some of the sessions in the last conference, the direction they went in, we understand what it takes to automate tasks in the network. I think we're in a pretty good place there. We understand that we need to have an intent. We understand how we go about enforcing that intent, inflicting it, which is the best word for automation for me, inflicting that change on the network to support that intent, validating that intent is actually being delivered. And if it's not, understanding why, and looking at that whole drift from intent. So closing the loop in a small way. But the challenge is that you can do that in one place, but the network's distributed.
Sure.
And so you've always got that concern of the unpredictability of the distributed system, of what impact that will have elsewhere. So the automation of individual tasks, absolutely key to this. But the bigger picture is, right, what actually is going on across the network? Now, thankfully, the network is deterministic, right? In theory, we should be able to make a change and know and understand the impact of that change. The thing is, though, our networks we build now are so blooming complicated.
Sure.
We've got so many different moving parts, and they all interact in lots of ways, and some more deeply than others. But ultimately, that interaction is the difficult bit to understand, and it's far too much for our human brains. So we need to do something about that. We need some way of being able to look across all of the technologies that are in that network, understand how those technologies are going to interact, and what impact that's going to have on applications and services that are laid across the top of that infrastructure. So I think that's where autonomy is a great idea, and definitely a direction we need to be driving in, because it allows us to dream, right? To get to have a target, but we're nowhere near it yet, because we don't have the full picture and we don't have that well understood yet. And I think this is the point. This is a nice introduction point, really, to our topic today.
So let me take you there, and as we've exchanged some ideas, here's something that came to me on a flaming pie. You'll be Beatles with an A. So a big barrier to getting to network autonomy is trust.
Yeah.
And if I understand this correctly, building your digital twin allows you to do so much what if and assess impact without inflicting it on the production network to test, validate, verify. So I see digital twin technologies as fundamental to something that can get us to autonomy. Agree, disagree? How do you think? How do you think about that?
I agree with you. Absolutely. I think when you look at the general use of digital twin in the broader sense, there's a well understood idea of using a data model that basically simulates the behavior of a closed system,
right,
and using that data model essentially to both look at the nature of that closed system as it is, but also be able to predict what will happen to it if certain things are changed. And absolutely, I think to be able to create that same view of a network, be extraordinarily useful and probably fundamental in reality to the idea of autonomy. Because once you have that, all of the aspects that you might have, all of the different elements that you might have actually making those changes and whatever, can use that single source of, and I'm not going to say single source of truth, but that single oversight of everything that's going on in the network to ensure and validate that what's going on is what you expect it to be. Absolutely key. Now, that said, we are not there yet, in terms of building that level of understanding of a network. And there's a few reasons for that.
Okay.
But let's start where we are now. The digital twin, the network digital twin, as we term it, as Gartner and whoever else we'll talk about these things to term it, is about having that data model, having that data source that will behave it's in the same way as your real network from a forwarding perspective. You're able, for example, to build all of the topology, all of the configuration, all of the state information that you've gathered from the network.
Sure.
You can drop a virtual packet in at one end, and you can see what that virtual packet looks like when it comes out at the other end, having been switched, routed, load balanced, firewall, natted, whatever, right? You go through the full forwarding plane to understand how it gets from one end to the other. So what that's going to allow you to do is test the behavior of your network without actually testing the behavior of your network, right? You don't have to put artificial probes in. You don't have to actually break things in the network to pull information out. You're testing a data model. But the beauty of it is it will simulate all of the different technologies. So you might have an SD-WAN environment. You might have a software-defined data center running VXLAN. You might have a campus environment running wireless. the digital twin will understand what all of those things do. It will understand where there's encapsulation. It will understand all of the impacts of those elements and give you a full understanding of what's going on from one end to the other. What it won't do, and here's the gap, what it won't do right now is simulate the control plane for all of those things. Because if you think about it, you've got to worry about everything from as trivial as MAC address learning and spanning tree, through routing protocols, through centralized control planes for a controller for your SD-WAN, for cloud infrastructure, and so on. And these all behave completely differently. The only way that you could really realistically do that right now, simulate that, isn't really to simulate it at all. It's to emulate it. Sure. And no one has enough compute power and memory and storage to emulate an entire enterprise network end to end right now, right? That's not to say that it won't happen. We've seen so many advances recently in especially when you look at AI as to what's possible. Mm-hmm. So I'm not predicting for 1 second that in 5 years we're not going to be able to do that. But you've got to start somewhere, and the place to start is very much with that data model in the first place. So that's where we sit.
So let me make sure I'm understanding. And this has been super clarifying conversation leading up to actually having this episode. Your digital twin is capturing the forwarding plane, the state of interfaces, not BGP sessions, not OSPF adjacencies.
Now, very specifically, IP Fabric as a product will do all of that as well, right? Okay. So we do gather all of that and we model all of that. We understand, if you think of it as a multi-layer diagram, topology diagram, what we'll do is we'll gather all of the where we can, all the physical connections between devices. Then we'll look at the layer 2 and we'll understand how that works at layer 2, where all the MAC addresses are, where, like I say, where things like spanning tree and stuff run. Then we'll go to layer 3 and understand where all the IP addresses are, where the subnets, and that's V4 or V6. We don't care. And then we'll gather the information about all that control plane activity because it's relevant. Sure. You still want to be able to analyze that. You still want to look at that. You still want to be able to say, right, actually, is this autonomous system connected to that one? What's the routing policy that sits between them?
Very good.
What it allows you to do is to make predictions yourself, but it's more of it's a probability game, right? Rather than anything else. It's like saying this will probably impact that, but it's down to you as a networking professional to understand that and be able to work with that. But if you go back down to the actual forwarding plane, the simulations are there and built in, and we'll take into account things like security policy and stuff like that. So those things can be tested and changed. But when it comes to dropping an interface and seeing what impact that has, there are so many links in the chain beyond that to a point where all of the control plane reconverges, that you've got to go through all that process first. So that's where the fun comes.
And there certainly is complexity in the control plane, given, even if you just had one vendor and one version of operating system. I appreciate the goal of having deterministic behavior of the network. That's why trouble tickets and network outages are so impactful, right? Because we're violating our assumptions of deterministic behavior.
Well, you say that. I mean, it's the simple fact is that most trouble tickets are caused by people making changes and not understanding the outcomes, right? Actually, you could argue that it is deterministic completely, and it's the people don't appreciate and understand it. But I hear where you're coming from.
No, that's a super helpful clarification. I guess I was overly focused on what happens when a NIC starts to go bad,
absolutely,
or a port on a switch, or a circuit from your WAN provider is dirty and you're taking errors, and it's but yes, there's plenty of stupid things done that we can can be determined deterministically what the impact will be of the shut command, for instance.
Very true. Very true. But I think that's something we've seen change over time as well, isn't it? That those kinds of issues that you do see that are less under your control happen less and less than they used to. I mean, we do have, generally speaking, again, I make generalization, the quality of the hardware is better, and fails less often. There's software, I think that's a vendor by vendor thing, but
I agree.
But certainly I think we're less impacted by those kinds of environmental and failure scenarios than perhaps we were previously.
I'd say that's true in the West. I think in other developing parts of the world, it's probably more like what it was for us in the late 80s into the 90s, right?
Fair play.
For sure. But there is an up and to the right. And, my whole introduction, coming out of an academic background in industrial engineering and operations research and really focused on system simulation. My first 5-10 years in the business, I did not understand why modeling and simulation was not more widely used. And I see the differences between what a digital twin is and does versus, a stochastic, injection of events into, a simulated system. They're not exactly the same, but everyone wanted to test it in the lab. Like nobody was going to trust what a report from a piece of software said. They wanted to see it work.
I think this is an important point, that what we've reached is this stage where we need, as a network engineering function or whatever, we need this support now. The complexity is such that you can't have it all in one head. So what you end up with silos, right? You end up with a specialist team over here who look after one technology, and then another team looking after another, and so on and so forth. And the challenge is that all of those technologies need to be deployed correctly in order to provide a service. And here's the thing, because the customer, your user, does not care about all of the different technologies and how they're deployed. They don't care.
Right.
That there are different people looking after different parts. They have different levels of understanding of what everyone else does. The point is that you're there to support a service, and that service is made to be available. That's what we're all here for. And so because of that, we need to build a better understanding across all of those functions, across all of those technologies. This is why it's time for the digital twin now, really, because if it hadn't been, 5 years ago, it is now. We need to have that understanding that we can help that poor network engineer sit in trying to make head or tail of what's going on to the left and to the right by showing it to them in a way that they can relate to, and be able to trace those application paths through it all to identify where the challenges might be if they have them. So.
And I do think the time series element to this is really helpful as well. To be able to go back, from putting my TAC engineer hat on, all right, I can see, what events led up, at least after the fact. What kind of use does that get from your users?
Yeah, I think that's a really good point. That and again, we spoke about this before. This idea that change is the only constant in any network, certainly of any size, and that could be anything from having to swap kit out because it's reached end of life to things just going wrong, or people making change and there being unintended consequences. All of these things are happening all the time. The supporting systems need to be kept up to date in order to be sure that when those things do occur, that the people who are there, those level one analysts on the NOC, are able to work out, right, who do I need to speak to? Where do I take those incidents? And if they haven't got the right visibility, they're in trouble. So what you need is that digital twin to be constantly updated, to be able to track that change history, to be able to pin down a root cause, because this that was like this yesterday and everything seemed to work okay now is not like that and everything's broken. So we can highlight that straight away because we have it in a data model, easy to spot. We can bring that information out and pass it through. And what you can then start to do is bring that into an observability platform, which is kind of where this goes, right? Is observability is a separate thing from the digital twin, but it's related because it's really about having, once you've identified there's a problem and where it is, it's about having the right information about that point in the network or that particular device or the application as it's flowing through a part of the network, to be able to zoom in on that and go fix the problem and get to that next level of detail. But it's much more near real time. The digital twin is often it takes a while to build it, but what it's going to do is it's going to be much more up to date than any documentation you had, right?
Sure.
So it's always the baseline of, right, what is the structure of the problem? That comes from the digital twin. Now, what's the telemetry that relates to that problem from the last N seconds? Right, I'll get that from my observability platform, and you put the two things together.
So let's talk about connections to other pieces of the ecosystem. One thing I want to just tease at a little bit is, you mentioned there are limitations on how much stuff you can store. So you're making some smart decisions on what to collect and what not to. And I want you to comment on the following. There's this tension between, with streaming telemetry, I can create my own big data problem, right?
You can.
And I can't collect everything about everything. That's going to be hurtful and harmful. And there's a US comedian named Stephen Wright he's really good with one-liners. And he says, you can't have everything. Where would you put it? Right. So
well, there you go, right there.
I don't have unlimited storage, but I do have more, especially with cloud storage services. I got to be careful. I could be genning up some incredible bills. But there's an enabler there. How has that, like in the last 3 years or 5 years, how have you seen that emerge?
Well, I think this comes back to that observability piece, right? Is you can have all that data, and that the data is great. There's kind of two parts to that then, because one is you've got to go looking for the needles in the haystack, right? Of what are the things that actually matter in the scenario that I'm looking for. And as a human, you're never going to be able to do that. That's just if we have a problem understanding how the network hangs together, how the heck are we ever going to find that one piece of data that tells me all? So then we start to look at correlation and these AI ops engines that can go and through machine learning, they can pick out correlation and have all the information. But again, if you're not gathering information from the right places, or you don't know where to look for the problem, what you're doing is you're hoping almost that the correlation can piece together enough information to do that. And again, this is where having that deterministic view of the network and its structure and its topology that sits underneath that then allows you to guide that your AI and ML to look in the right places, because you can turn around and say, well, look, this application for a customer, for a user who's in this location, they're going to go through this wireless infrastructure here, this AP, this switch, this router into this WAN across this link into the DC, then to a workload that lives on this particular leaf switch, let's say. So you've mapped out that, you understand where all of the elements are of that application flow. Now that's really narrowed down the data that you have to go searching through in order to find out what's causing those problems. So it's just a really useful context set, I suppose, for the for finding that needle in the haystack.
It's not a needle in a haystack; it's a needle in a stack of needles, right?
That's exactly what it is, right? Yeah. Ultimately, because otherwise, that's right. You'll find the observability platform will find all the needles, but you need to find out which needle is the one you're looking for, right? So,
right. Have you developed either recommendations or best practices, or just have a sense of what's good to collect and put in the digital twin, and what really doesn't provide a lot of value?
Yeah, I mean, the approach that IP Fabric takes is to look basically our our data model is vendor neutral, right? So what we do is we gather the information that's relevant across all of our vendors.
Sure.
And so what that does is kind of naturally is it gives you a selection criteria as to what data to collect and what not to. It's all about what you need to validate that a path from one end of the network to the other. So it's all the control plane data that allows you to create the state for the forwarding plane. So and therefore all the inventory information and so on about the devices. What we're not going to do is gather every single configuration item and whatever for vendor specifics. We capture that information and stash it to one side, but we don't bring that into the data model because it's really about understanding what that flow is going to look like. So it's literally all the information that you need to get from a packet from one end to the other. So, I mean, that's the way that we do it, because that's the way if you or I was sat in front of a network and we had to sit down and work that through, that's the information that we would need. So all of the things that we would need to do our jobs, that's what goes into IP Fabric's version of the network digital twin.
For sure.
What that does then allow you to do is start to do some interesting stuff around compliance checking and that kind of thing, right? Okay, what can I validate that all of my devices, regardless of which vendor they are configured for this type of management approach? This I don't know, this SNMP, this logging, this NTP, or whatever. And I don't care whether it's a Cisco or an Aruba or an Arista or a Juniper. It doesn't matter to me.
Sure.
Just do that for me. It gives you a whole bunch of insight automatically that you just don't have to go searching for. And I think that's where we've sort of drawn the line in our approach, is very much what are the things that a network engineer actually is interested in pulling from the network.
And I can see the roots of, hey, we're just trying to figure out how to automatically discover a client's network infrastructure.
Yeah.
To like showing you, okay, what's useful and what can we ignore, or maybe not place as high a priority on, and then bring the right bits together. Yeah,
absolutely. I mean, but the things like when you're looking at a topology, trying to, we take it as given when we build networks that we have redundancy and resilience and those sorts of things. But are they there, or do they have the impact we expect them to? So one of the things we can do, because we have the data and it's relatively straightforward once you have the data model, look for single points of failure. Look for loops. Look for multiple paths that allow you, to fail over from one to the other. So long as you can set the parameters for those things and understand what it means to do that, it's a graph database problem at that point. But it's not just about having physical links between two places. It's making sure that the physical links are there, that they're supported at layer 2, that they're supported at layer 3. That they're supported, in the routing protocols as well, all the way up the stack. We have to go as far as is possible to make sure that the network engineer can turn around with confidence to their users and say, look, the network is going to support your application from top to bottom. And that's what we're there for.
So speaking of top to bottom, you've touched on quite a few specific, these are ways I use a digital twin. I wanted to give you an opportunity to comment on any other specifics on how ops teams do interact with the tool, how they use it, but also get us to the topic of, hey, remember, we're supporting business services and mission. We have to elevate above that. I know that's maybe a contradiction, but I'd love you to speak to both of those things in order. What are there any other specific ways that you can tell the network operations audience here's other specific things that we see our customers doing, using our digital twin instantiation?
Well, there's a few things. I mean, the key to it all is to have a complete picture of the network. So few places. When you rock up there for the first time, and our co-founders, this is the problem they had. Do you know for sure that you know everything about your network top to bottom? Every switch, every router. Do you have all of the information, all the configuration stored, and so on? So to have that initial discovery piece to be able to say, go find the boundaries of my network and tell me what's there. Our process and other people working in the same space have a similar process. It's all about making sure that you're not just relying on discovery protocols and those sorts of things,
right?
But you're looking at all of those layers to determine what's out there. We, for example, when we discover a network, we don't stop where we run out of credentials or whatever. What we'll do is we'll look at the edge of the network. We'll understand, right, does it have a CDP neighbor relationship? Yes, no, well, fine. If it does, great. But if it doesn't, we'll look at layer 2 and see if there are things out there that we didn't know about. We'll look at layer 3 and look for next hops that are outside our scope. We'll look for BGP relationships with things that we can't control. And you'll get a full picture of everything that's of the complete scope of your network infrastructure, because you're going to find things that you weren't expecting to be there, right? We all know about the hubs that are plugged into switch ports under people's desks and those sorts of things. Those things were real, are still real, right? That people do those things, and that obviously opens up a whole bunch of security side of things. So
there's still Apple talk out there. There's still netware out there somewhere. Yeah, that's right.
IPX. I mean, it's. I think recently talked about this one. IPX is still there, and we'll come back to that later, because there's a story about one of my biggest gaffes with IPX, but we'll talk about that in a bit. But that's exactly the point. That there's always going to be things there that you don't know about, and the challenges that brings span far and wide. Because if you don't have a full picture of what your network is, then your procurement people are going to want to know where things are and whatever, because they need to deal with your support renewals.
Right.
Your monitoring system won't tell you what you think it will tell you, because you don't have a full inventory in there. Your automations are going to get you so far, but not as far as you need them to, because you don't have a full picture. So straight away, just that bare minimum of the inventory allows you to reach out to different teams around you in order to make sure that they're seeing everything that you are. But then, and of course, from a documentation perspective and those sorts of good things, hell, you don't need to draw diagrams anymore, right? I mean, that alone for me was an absolute boom when I saw that for the first time. And as a result, you're not just enriching your understanding of the network, but you are ensuring that all the other sort of platforms have a solid foundation to be built on. I think that's where this becomes really visible, because all of a sudden then people can start to rely on those tools that we've spent years manually configuring these things, monitoring platforms where when you make a change, you go, oh, yeah, that interface doesn't connect to that thing anymore. It connects to something over here. So I better change the priority of that. So when it appears in my list of red alerts on my thing, it comes a little bit higher than it did before or whatever. It was a manual process to go through that every time you'd make a change, because it wasn't just documentation that needed to be updated. It was the tooling as well. Well, how about you automate that process so that you don't have to do that anymore? The opportunity for service improvement is massive as a result, particularly because you can now map the applications across that infrastructure and start to understand the dependencies between the things that the customer cares about and the things that you're responsible for.
Here's one reaction I would have to all of this. If I was trying to do all this work and intentionally document my processes and workflows and figure out how to automate them without a digital twin, then I had a digital twin to help me go deeper and have more comprehensive view. I think I would never want to go back to not having a digital twin.
It was the very thing I said so my very first interview with Pavel, our CEO, the co-founder. Why have I not seen this before, and why have I not done this before? Because you do instantly. You just realize the difference that it could have made to the way that you've done things over time. I've spent years consulting into customers where you have to sit down and work this stuff through. I
Yeah.
wrote Python scripts for days to go gathering this information. And that's fine, but it's only going to gather the bits of information you want. It's not going to give you all of this extra insight about, right, actually the interconnectedness of it all and the way that those things interact with other parts of the network. There was a great example when I was a consultant before this role. I was in with a hospital trust, and in the UK we have our NHS, and
Sure.
they're arranged in these trusts that essentially are separate organisations looking after multiple hospitals. This one trust had 4 hospital locations, one of which was brand new. So they had great documentation. They'd got all the information from their systems integrator with all the documentation. Everything was fantastic. They had another one that was 100 years old that had been grown organically over time. It was all kinds of horrible kit. No one
Sure.
really had a great picture of what it was like. They had another one that they'd acquired from another trust, so they didn't really have much of an idea of what was there at all. It was okay, but it was pretty grubby. And the other one, no one really knew what was there. It was just something that had appeared one day, and all of these 4 were interconnected. All of them were running different technology, different generations of Cisco kits, and so on. And what they'd asked us to do was come along and plug in cloud into this. Just come and plug a bit of cloud in. It'll be fine. We'll move everything to the cloud. We can get rid of a data center. Great, brilliant. The problem was, as soon as we plugged the cloud in, as you do, you could only see it from 2 of the 4 locations, and no one understood why. And we spent 3 months getting to the bottom of this. A team of 3 consultants we had working on this one, because they had to sit down and re-document the whole thing top to bottom in order to understand why it was. And the fact was, they had 4 different instances of OSPF. They had 2 different BGP ASs. They had a whole range of different policy for redistribution between all these. It was just an absolute car crash. And it was a miracle that anything would route from one end to the other at all. So there's just no way that you could have got to the bottom of that without going through that process. And literally the first time I sat in front of the product, and I realized that one snapshot from IP Fabric could have solved 80% of that in one hit. And so it's like, when you see that happen, you look instantly, why would I do this any other way?
Yeah. No, I can see that for sure. I haven't had a chance to play with this in a real production network, but like I can see the value.
Yeah.
Let me Yeah, go ahead.
I think it's and yeah, I mean, obviously we're talking about IP Fabric specifically, but the digital twin itself in whatever form lends itself to this, because it's all about having a data source that's trustworthy, and I think that's the key to it.
And another point that that has made me think about, as we came up with, okay, what discussion points do we want to talk about? What are the connections between digital twin and AI? I'm like, well, you're presenting the data that needs to be crunched, and I've been able to crunch that data in certain ways. Using it to populate a graph and using graph theory. There's probably other statistical techniques I can use. And now I have a whole other set of techniques with LLMs and machine learning to process that same data. How is IP Fabric thinking about that?
You've got a couple of things there. I mean, again, we've talked a little bit about prediction and that kind of thing. And here's the perfect opportunity to perhaps start looking at those techniques to use that data for that purpose, right? If we can train the models in the right way, we can use them to at least start giving us probability of predictability based on rule of thumb, rather than by brute force running all of the control plane protocols and technologies. So there's absolutely that's one area we're looking at. The other comes all the way back to autonomy that we were talking about at the beginning, right? The idea of having these autonomous AI agents, this army of agents, I heard someone call it the other day, which was awesome. um, who are essentially operating as co-workers, right? Looking after very small fragments of the intent that's needed for that network, creating their own small closed loops. But the way that they can understand everything else that's going on in the network is to refer to that digital twin. So if you have an agent does a thing and another agent does a thing that overlaps with that thing, so long as the digital twin's up to date, you can see the impact one has on the other. And I think that's somewhere where we're going to get a lot of traction ultimately, because how else could you do that other than telling every agent that they have to all go and look at the network and find out what's going on in order to get that picture end to end. So it's almost like a proxy for the understanding that you would get by inserting a human into the process. And it's all about that. It's about saying, look, you don't need to have, for every process that you're going through, every workflow, you don't need to inject a human with the full understanding of the network into that process. You can use essentially a data source that the manual processes can use the data source as well. So you can gain trust through interacting with that model. But once you've gained that trust, you can then use the API and ultimately, say, an MCP server or similar to dip into that data and use it to guide your AI agents. And I think this is where we reach that point of inevitability. So, our CEO always talks about this as being an inevitable technology. There will come a time when, as you said, I've used a digital twin. Why would I ever go back? There will be a time when everyone has a digital twin of their network simply because they need it and they see that they need it, and there's no reason for them to go back to try and do things manually afterwards. And we believe that this idea of autonomy, this idea of the AI agent, is the time where this becomes inevitable.
With that being said, let me, at the risk of maybe being a little too science fiction-y, what are you seeing about the possibilities for federation, where, if I'm an enterprise and I'm using a carrier or set of carriers for certain WAN circuits and other transport services, and maybe I'm dealing with two different providers who also have their own digital twins, we're seeing this really interesting evolution with MCP being this reference point for organizations to share information and let agents go at it. I'm not asking roadmap questions for IP Fabric, and I'm not putting in a feature request, but how far off could something like that be?
I think genuinely this is where it gets really, really interesting, because we have customers at the moment who come to us and say, look, how do I know that my service provider is giving me the service I expect of them? The way that we work at the moment is it's like we get them to make an agreement with their service provider that we can extract data from their network and bring it into our model. There's no reason why you couldn't extend that to some sort of federation, as you say. And MCP, what a great way of doing it, because ultimately, trying to keep on top of everyone's API specs and so on is a painful thing enough as it is.
Oh no, to be able to do it the consistency is so high and security.
those standardized data models.
About,
yeah, exactly. And so certainly we're seeing the likes of MCP and A2A and these sorts of things as being opportunities to, while we care about the structure of data and so on, to be able to exchange that information and then be able to translate it back to the thing that we need, is something that we're sort of investigating quite heavily. But it's top of a lot of people's minds right now. It's really interesting that literally in the last year, people have really started focusing on, actually, how do I make this data available in a broader sense to the people who need it, without resorting to coding or whatever through APIs. MCP has really sort of, even if it's not the technology that we use, sort of in the long term, it's opened so many people's eyes to what the possibilities are. So
here's a connector. Here's one way of connecting, and even
natural language. What a great way to do it.
That's a killer app. I think natural language is the ultimate expression of intent. So we're now entering the age of intent-based networking, because now I can just say, hey, can you tell me what's going on with this site? Why am I seeing these log messages?
Yeah.
And I say it in a somewhat snarky way, but I do think we've crossed a threshold with that. So
there's definitely, we're definitely on a path. I mean, the ambiguity of the English language, amongst others, is
sure.
will probably sort of give us cause to not necessarily jump in with both feet, but yeah, I think absolutely there's a path there for sure.
We'll crank through that, and look,
yeah, agreed.
Non-determinism from LLMs is, in a sense, no different from non-determinism from other humans.
True enough. True enough. Just look at us, separated by a common language, right?
Exactly.
It's a fact. So
I love one of the things that I always catch between British English, I'm sorry, real English and American English, is what you make plurals of and singular of versus what we do. And it's always been a funny thing to me. Sorry.
No. For me, it's spellings that
sure.
get me every time, because I now try and write in American English just because that's marketing, right? My spelling check always tells me I've spelled things wrong, even though I'm using the American spelling. So yeah.
I do. My short understanding of that was Noah Webster trying to make the first American English dictionaries, intentionally tried to simplify. So getting rid of lots of U's in neighbor and color, etc., was like a defining feature. So
nice.
I'm sorry that your spell checker still wants to use there. I get it.
It's the Z's as well, right? Yeah,
I like
the Z's and the S's.
Yeah,
but the Z is actually more Old English than the S's. So that's us being influenced by the Europeans, apparently. So there you go.
I as a person of Norwegian heritage, I also know the Vikings brought a little bit to the British Isles as well. So
just a little bit, yeah.
Well, look, as we try to wrap this up, the last topic for you to comment on here would be, there's lots coming at this generation of network engineers. Some things have changed, but there's so much more tooling and capability. What do you think are the requisites for the network engineer to survive and thrive in the environment that is already here and is to come?
I mean, it's the same as it's always been. Fundamentally, I think is that from your interview with Vint Cerf, he used that term relentless curiosity, and I think that, for me, head and shoulders above everything else is the key. I mean, that's the one thing that I've always prided myself in that I've always been learning, always been looking to the next technology and so on. And I don't think that's any different now. If anything, it's more important now than ever, because things are changing so quickly. So that importance of understanding the broader context than focusing in necessarily on one specific group of technologies is always going to be key, because who knows what happens next. I mean, we've talked before about the problems of automation, people worrying about what it does for their jobs and that kind of thing. Well, ultimately, if you're looking forward and you're always thinking about other things, you've always got options, you've always got places to go. And to going back to the Willy Wonka movie back in the day, where it was about screwing the tops on the the dad was in the factory screwing the tops on the toothpaste tubes, and then he was the guy who became the one who looked after the machines to screw the tops on the toothpaste tubes. That's, for me, that sums it up completely. It's all about
that. I'm going to reappropriate that example.
Honestly, it's brilliant. It's brilliant. But I think that's the point. Is that always look for the next thing, and so as a result, we've had so much emphasis on network engineering people being educated in programming and whatever through the DevNet program. Great program from Cisco. They did a brilliant job with that to start us down the path. But as we've seen, and we've talked about today, it's much broader than network people becoming programmers. So be aware of everything else that's going on. Be aware of what's around you, and that those the AI techniques and the things we've talked about MCP and those sorts of things. Follow the right people who are doing the experiments. Understand where those are going to take you, but form your own opinions of how they make things better, and follow your gut. Really,
For sure. I have to ask you the final question, and I will give you the digital. I'll give you the digital twin version of the question, as is appropriate for this particular episode. So you, by your own admission, 10 base 2, you've seen a lot.
Yeah.
And you've obviously been turned on to the benefit of, wow, now this, having all this information in the form of a digital twin. Is there an outage scenario that you saw, or maybe even caused, that may have been prevented with having a digital twin? Or if you don't want to be that bold and admit to taking down, some trust's healthcare network, have you seen interesting examples? You don't have to take personal responsibility, but
no, there's a couple. I mean, I mentioned, so the first one, probably, I don't know if a digital twin would ever have saved me from this one, just because it was so basic. My very first day in my very first networking job, I was sat in front of the management console for a managed hub. Most people won't even understand what these things are.
Sure,
but it had a backplane that was separated into two networks. I inserted a blade into this thing, connected it to the wrong network, and all of a sudden I heard a beeping going on in the corner. Now, again, for those of you who don't know NetWare, you won't know what that beeping was. For those of you who do, you know exactly what I'm talking about. I basically crossed the streams. I got two networks talking, bridged that shouldn't have been, and a room full of about 40 NetWare servers all lit up and beeping. The digital twin wouldn't have helped me there. I mean, that was just one of those things. That was a whole university's compute resource there telling me I'd made the mistake. So, the phone lines soon lit up afterwards.
For sure.
But from the digital twin perspective, actually, when I was consulting, I looked after a particular customer, and we were deploying technology called OTV, which is a Cisco technology.
Yeah, it rings a bell.
Yeah, it's basically a tunneling technology that allows you to extend layer 2 between two data centers. And it was fine when it worked. It was fine and it did its thing and whatever. As I say, it was about tunneling packets from a VLAN in one location to a VLAN in another, and allowing you to effectively bridge over this tunnel. All good. But when we were doing some tests, we pulled one particular link and we failed over to the second link, and everything seemed fine. Everything seemed fine, but I was unable to authenticate a new login to one of the switches. It was a bit strange. Turned out that what I'd found was a path through the network where there was an insufficient MTU to carry that tunnel traffic. Unfortunately, I configured that link, so I got a lot of grief for that. But of course, if I'd have had the data about my MTU configurations throughout that environment, I could have checked that beforehand, and that probably would have saved me a lot of grief. Every time I spoke to that customer thereafter, it was MTU was all they could talk about. So unfortunately, but yeah, and it's a great example of having the right understanding of the network, being able to make sure that you're not going to make those kinds of changes.
Very, very well played on both responses there. Thank you. Thank you so much for that. Is there a place you want to point people to for any writing, blogging, or other content you produce, or IP Fabric, or both?
I was going to say my stuff is primarily on LinkedIn. I put pretty much everything on there. I've kind of gone off the other social platforms because noise and whatever. Sure. LinkedIn seems to have, for me at least, become the de facto place. So I do occasionally do guest blogs for various other folk. I've just done one for the publishing folks, so I
Sure.
can give you a link to that one, which actually is on this topic. So so it fits in quite nicely. But otherwise, IP Fabric's blog and website are the best places certainly to find out more about the product. So and again, ipfabric.io is the place to look for that. So
excellent. Well, Darren Fulwell, Darren with one N, Fulwell with three L's, first one and then two.
Of course.
Super to have you here today. Thank you so much for coming on Total Network Operations.
It's always good to talk, Scott. So thanks for inviting me.
Absolutely. I don't ever have to be the smartest guy in the room again. Not that I ever was, because I get to have all the smartest people on this conversation. You talk about learning and lifelong learning. I learn something from every one of these conversations, and it's
I'm very envious of that, because as you know, I listen to every episode, and I'm always learning new stuff as well. So I appreciate the keep it going, my friend.
Thank you. Your commentary is always very kind, perhaps too kind, but always appreciated. And to the listeners, hey, you have the door open for feedback as well. If you've got somebody you want us to have on the show, you have something to say about NetOps and where things are going, send me a DM on LinkedIn, hit me up on packetpushers.net/follow-up. Would love to talk to you and see what you want to talk about. Thanks again for tuning into Total Network Operations. Enjoy the rest of your day. Bye now.